Today is part 2 of 7.4 fractional equations. We're going to have word problems on them. So now here's example 1. It says find the sum of a number and its reciprocal, which is 13 over 6. So now you all have your worksheet there. You don't have to write this down, but think about this. How many unknowns do we have in this? How about, let me pick somebody at random. How many unknowns do we have here, Brendan? 1. What is the unknown? X, the number, right? So it says the sum of a number and its reciprocal. So actually there's another unknown, even though you could actually get the other unknown using the x. So what do they mean by the reciprocal of this x? How would you represent that?
1 over x.
Exactly, 1 over x. Would you not agree? So we're going to say let x to be our number, then what? 1 over x is the reciprocal. Right? So you could say there's just one unknown, but really there are two, right? The number and its reciprocal. And you could represent it by doing it this way. Is this pretty straightforward? This is what we've been doing all this time, right? Throughout the whole year. This is the same exact step. We look for the unknown, we declare the variables, right? And of course, that's our step 2. What do we do next here? We need to come up with the equation. Thomas, what do you think the equation for this problem will be?
X plus 1 over x is equal to 13 over x, 6.
Exactly right. They say that the sum of the two numbers, right? So x plus 1 over x, and it equals to, it says is equal to 13 over 16. Pretty straightforward. And now, do you see how we get a fractional equation? Right? We have an equation where variables in the denominator, one of the variables in the denominator is, the denominator of the equation is some variable. Okay? So we got x plus its reciprocal 1 over x equals to 13 over 6. Do we all know how to solve this equation? Yes, we do. Okay, guys, you know how to do this. We did this yesterday. Multiply both sides by the LCD. Go ahead, everybody try. And of course, you may ask your group. Okay, that's fine. Work as a group. Okay, help each other out. Go ahead, I'll wait. So, we're going to multiply both. First of all, we said that the LCD was 6x, correct? But not only that, we have to be mindful of something. What do we have to be mindful of? Rania? The restriction. What is the restriction for this equation? X can't be 0. Because if x was 0, then you get 1 over x. That's, undefined. We don't want that. So good. I'm going to actually write that down up here so I don't forget. Right here. Is that okay, guys? I wrote down my LCD. This is what I'm mindful of. My LCD is 6x, and then I know that x can't be 0. So after I solve this, if I get the answer x equals 0, then I can use that as my solution, right? All right, so we're going to multiply both sides by the LCD. Somebody tell me what we get on the left side. Of course, you got to distribute that because you have two terms. Ria, what do I get?
I'm getting 6x squared.
Good.
Plus 6x over x.
Which is simply 6.
Equals 13x.
13x. 6 is canceled out. Very good. Very good. Did you all get this? You see how nice this equation becomes when you multiply both sides by the LCD? But because we're multiplying both sides by something with x, we may be introducing more solutions to this, okay? So of course at the end you got to check. But it does become very nice and we know how to solve something like this. But we have x to the second power, right? So that kind of shows us that, oh, we have to make it equal to 0 and use zero product property, right guys? Remember? It's not a linear equation anymore. If it was linear, it'd be easy. But we have x to the second power. Now it becomes quadratic. So you got to subtract both sides by 13. And of course the whole thing equals to 0. That's what we want, right? We want the whole equation equal to 0. So we could factor the left side. Okay, so how do we factor 6x squared minus 13x plus 6? Some of you got this right. How about, yes, Kira? How does it factor to? Remember, we got to do that vertical way, right? You know that 6x squared. Which one are you going to try first? Sorry. Which one are you going to try first? 3x times 3x or 6x times x? I mean, 3x times 2x or 6 times x. Which one should we try first? 3x times 2x. Remember, I told you to try the one in the middle. So, Kira, what'd you get?
3x plus 1 times 2x minus 5.
Does that work? I got...
Oh.
Yeah, you should have 3x minus 2 and then 2x minus 3. Doesn't that work? Doesn't that work, guys? Yeah. So that's the one that works. Because if you use 1 and 6, it doesn't... You don't get negative 13 in the middle, do you? Let's verify. What is 2x times 3x, guys? 6x squared. What is negative 3 times negative 2? Positive 6, right? That's the easy part. Let's see whether we get to negative 13. 2x times negative 2, what is that?
4.
Negative 4x, right? What is negative 3 times positive 3x? Negative 9x. What is negative 4x plus negative 9x? Negative 13x, right? You see how we have to check, right? Do you see how we go back to all this factoring and so forth? So this is only true if what? So we're going to use zero product property, right? It says something times something equals 0. That will mean that each of the factor, if each one of the factors is 0, then the whole thing is 0. So we set each of these factor to 0 and see which one works. So this is only true if what? 2x minus 3 equals 0, or what? 3x minus 3 equals 0. For the first one, we're going to add 3 to both sides and then divide both sides by 2. So the second one, we're going to add 2 to both sides divided by 3. How many forgot? 3 over 2 and 2/3. That's the answer. Very good. Okay. If you didn't, do you see how we get 3 over 2 or 2/3 as the answer? Now we have to verify. We have to check, right? So how are we going to check and see whether we got this? Let's go back to our equation. What do? We do x plus the reciprocal 1 over x, right? So let's check with. So here you gotta check. Let's try with 3 over 2. What is the reciprocal of 3 over 2? 2 over 3, right? Isn't that 1 over 3 over 2? That's the same thing as 2 over 3. So when you add them together, do you get 13 over 6? How are you going to know whether we do or not? We have to get a common denominator because we're adding fractions, right? So let's see whether it does check, doesn't it? Multiply top and bottom of 3 over 2 by 3 over 3, 2 over 3 by 2 over 2, right? Then you get a common denominator of 6. So you get 13 over 6. It works. What about the other one, 2/3? Do you think 2/3 will also work? Did you guys try? Let's check. 2/3 plus, what's the reciprocal of 2/3? 1 over 2/3 is the same as, it's really 1 over 2/3, right? Does it equal to, put a question mark, 13 over 6. Does it equal to that? Well, 2/3 plus, what is this? What's 1 over 2/3? 3 over 2, reciprocal. Does it equal to 13 over 6? And I could tell you it does right away. I don't have to do anything. Why? It's the same as what we have over here, right? It's now just heading the other way around. And it makes sense. You see how 3 over 2 and then 2/3, they are the reciprocal of each other? Right? So if you add 2/3 plus 3 over 2 is the same as 3 over 2 times 2/3. So both of them works, and it makes sense why both of them works, right? Because one of them is the reciprocal of the other. So what's the answer? How do we write the answer as? The number is what? 2 over 3. Or you could say 2/3. In both cases, it works, right? Doesn't it? Right? If you try 3 over 2 plus its reciprocal, you still get 13 over 6. And if you do 2/3 plus its reciprocal, you still get 13 over 6. There are two possible answers for this. Okay? And it kind of makes sense. They're reciprocal of each other. Okay. Haven't forgot the answer? 2/3 or 2 over 3. Does this make sense now? If you didn't, do you see why? These are the answers. Right? There are two possible ways for this to be true. Okay? If you add the number and it's reciprocal, 13 over 6, it comes out to 13 over 6. Okay? Are we good? Easy enough? Is this a nice review of what we did yesterday? Yes? So today, all you have to do is translate the word problem into an equation, and right? Rest is the same as what we did yesterday. Does that make sense? Are we good? Okay. So let's do example 3. Example 2 is very similar to example 1, so you could do that. We could do that later if we have time. Example 3 says, can you put positive numerator? Because there's a typo. I forgot to put that in. The positive numerator of a fraction. Okay, so can you put that in there? I forgot to. The positive numerator of a fraction is 1 less than the denominator. If the numerator and the denominator are both increased by 4, the new fraction will be 1/8 more than the original fraction. And of course, they want you to find the original fraction. So, take a look at this. How many unknowns do we have? Okay, show me with your fingers. How many unknowns do we have here? Not all of you know? Okay, think about it. I want 100% participation here. How many unknowns do we have? It says the positive numerator of a fraction is 1 less than the denominator. If the numerator and the denominators are both increased by 4, the new fraction will be 1/8. Okay. Show me with your fingers how many unknowns we have. Very good. They are? How many? Show me with your finger. 1, 2, 3. There are 2. You guys are correct. Okay, some of you said 1. There are 2. So I know why you said 1, because if you know the numerator, you know what the denominator is, right? But really, we don't know what the numerator and the denominators are for this fraction. Correct? So I'm going to let x to be what? Numerator or the denominator? Yeah, denominator might be better because then you could just add 1 for numerator. Let me see what I did. I said x to be the numerator. Is that okay? Let's just do it that way. It doesn't really matter. But yeah, then the denominator, as we said, you just have to add 1 to it, right? Because the numerator is 1 less than the denominator. So whatever the numerator is, you add 1 to it. That's how you get the denominator. Are you okay there? Do you see how I chose the numerator? Could you have chosen the denominator if you wanted to? Yeah, if you did, then what would it be? All right. The numerator then will be? X minus 1. Yeah, but I like addition, so I left it this way. Okay, are we okay here so far? So, who could tell me then? Here, these are the 2 unknowns. Let x to be the numerator, then of course x plus 1 is the denominator. They told us numerator is 1 less than the denominator. Okay, so how are we going to come up with an equation? Go ahead, everybody think about this as a group. Read the rest of the problem and see if you can come up with the equation. Go ahead, help each other out, guys. So, first of all, Sabrina, what is our, it says the numerator and the denominators are both increased by 4. What does that mean? What does, if the numerator and the denominators are both increased by 4, what does that mean?
So you have like x over x plus 1.
Good, I like that. That's our original fraction, isn't that right? Our original fraction is x over x plus 1 because x is a numerator, x plus 1 is a denominator. Then what do they want you to do with that?
They want you to add 4 to both the numerator and the denominator.
Tell me what to write.
So it'd be x plus 4,
Mm-hmm.
and then x plus 1 plus 4, which is really just x plus 5.
Exactly. So there you have it. That's what they mean by if the numerator, thank you, if the numerator and the denominator are both increased by 4. Do you all agree? Notice I used the parentheses here because I'm adding the whole thing to it. And Sabrina said that just becomes simply x plus 5. Now, now this is the new fraction, right? What would this new fraction equal to? It says the new fraction will be, it's kind of like will be or equal to, right? What? 1/8 more than, guys, more than, what does that mean? Do you do 1/8 plus something, or is it something plus 1/8? Something plus 1/8. What is that something? X over x plus 1, the original fraction. How many forgot this as the equation? That's the equation you needed. How many forgot this? If you didn't, do you see why this is what they're talking about? This is really important that you understand, right, exactly what they mean by this, okay? And of course, what are we going to do first? Always simplify. Should I leave this denominator as x plus 1 plus 4, or should I leave it as x plus 5? X plus 5, right? That's what I would do. Always simplify. So when you do, okay, always simplify. I wrote that down here. Okay, so there it is. Okay. Now, does this mean x over x plus 1 plus 4? Is that what they meant? Could you write this? X over x plus 1 plus 4. No, they want you to increase both denominator and the denominator, right? You can't denominator and the numerator. Did I say? Numerator and the denominator. All right, so what is our LCD for this? Now, you should always simplify because it's much easier to figure out the LCD. Now, Elisa, over here, what do you think? What is going to be our LCD in this? Exactly. It's basically this time, none of them they don't have any common factor, so you multiply all the denominators, that's your LCD. So your LCD is 8 times x plus 1 times x plus 5. Isn't that right, guys? What about, how many unknowns, how many restrictions do we get in this? How about, and what are those? Destiny, how many restrictions do we get?
You get 2 restrictions.
Mm-hmm. What are they?
N cannot equal -5,
Mm-hmm.
n cannot equal -1.
That's right. -1 and -1 or -5 can't be x, or you said n. Yeah, it doesn't matter which one you use. Does that make sense? So we're going to multiply both sides by the LCD, right, guys? Yes, go ahead, everybody do that. And of course, be mindful of the 2 restrictions. X can't be -5 or x can't be -1, right? See what you get. You got to simplify then. And the whole thing really becomes a nice equation without any denominators, right? Once you multiply both sides by the LCD. Go ahead, everybody try. So here, as you can see, we're going to multiply both sides by the LCD this time. The LCD happens to be the product of all the denominators, right? Because you didn't have any common factors. So when you do this, on the left side, x plus 5 will cancel out with x plus 5, correct? Because those are two factors. And you end up getting 8 times x plus 1 times x plus 4 on the left side. Do you see how that works out there, guys? It just simply becomes that, right? Because x plus 5 cancels out. Here on the right, you're going to have to distribute. Because you have two terms, you're going to multiply twice, right? So x plus 1 will cancel out with x plus 1. For the first term of this right side, you get x times 8 times x plus 5. Is that okay? Am I done? No, you got to add. Now you have to multiply 1/8 times that LCD. Now this time the 8 will cancel out. What's left, class? X plus 1 times x plus 5. And now this, right, this is what you get. Now, because we want to gather all our like terms, we have to get rid of all the parentheses, correct? Right? So what is the best way to multiply the three things on the left side here? Should I multiply 8 times x plus 1 first, or should I multiply these two binomial first? Multiply the binomial first and then distribute 8, correct? Here, you could just multiply 8 times x and then distribute, because here it's just two terms. Do you see how you get 8x here? 8 times x, distribute, and then here, you just multiply these. So first of all, what do you get when you multiply x plus 1 times x plus 4? You get 8 times x squared plus what? 4x, and then 1x, 5x, and then here, 4. Would you not agree? So you just get that. Very good? And here, 8 times x plus 5, you just simply get 8x times x plus 5. Here you get x squared plus 6x plus 5. Correct? Because you get x times x, which is x squared. X times 5x, which is 5x. And here you got to add 1x to it. You get 6x. And then here at the end you get 5. Okay, now you need to simplify. I multiply this now. 8x times x plus 5. We get 8x squared plus 40x plus here x squared plus 6x plus 5. On the right side, you want to simplify. When you do that, do you see how we have like terms? 8x squared and x squared, you get 9x squared. 40x plus 6x, you get 46 equals plus 5. The left side stays the same. Now, let's get rid of some of them. Which one should we get rid of? 8x squared or 9x squared? Class? 8x squared. Subtract both sides by 8x squared. Subtract both sides by 40x. Subtract both sides by 32. Because we want the whole thing to equal to 0. Right? Because we have an equation that is not linear. We have a quadratic. So when we do, you should have gotten x squared plus 6x minus 27. How many people got this? Equals to 0. Good. If you didn't, a lot of you did. If you didn't, take a look at it. This is what you should have gotten. After you simplify all this, you should have gotten 0 equals to x squared plus 6x minus 27. And of course, all we have to do is what? Factor that trinomial. This time it's easy because the leading coefficient again is 1. It's easier to factor when, right, the leading coefficient is 1. Does anybody know how this factors to? Okay, Angie?
X minus 4x.
Correct. X plus 9 times x minus 3. You can verify, right? X times x, you get x squared. 9 times negative 3, you get negative 27. X times negative 3, that's negative 3. 9 times x is 9x. When you add them together, you get positive 6x, right? Very good. And this is only true then. How many solutions are you going to get? 2. So you get 2 solutions. E-ray, what are the 2 solutions? This is only true if what?
X equals x equals negative 9. I mean,
Right.
X equals 9.
No, this is only true if x plus 9 equals to 0, correct? Or what? This is only true if each of the factors are 0.
X minus 3 is
Yeah, x minus 3 equals 0. Now you have to solve. So be careful. People just do this in their head and then mess up. So E-ray, what should you get? When you do this, you subtract 9 from both sides, so you get x equals to negative 9 or x equals to 3. There are 2 possible answers. Can x be negative 9? Why not? Some of you say yes, but you can't be because if you look at the very beginning, who could tell me? It turns out you have to drop that one. Why do we have to drop negative 9? How about Zareth? Okay, let me help you, Zareth. Look at the very question they asked. What did they say? What kind of numerator? The numerator has to be what, Zareth?
1 less than the denominator.
No, look at the very first part. What kind of numerator is this? Positive. So can x to be, we said x was the numerator, can x come out to be negative 9? No, so we got to drop that one. Does that make sense? We said that we want a positive numerator. Okay. So therefore we drop, then so x has to be then 3. Does this guarantee that 3 is the answer? No, because we multiply both sides by some variables, you have to always check, because you may have introduced some solutions that weren't part of the original equation. So you gotta check. How do we check this? Well, you plug it in. If x is 3, the numerator, how do you figure out the denominator? Yes. It's one more than that. So it's 3/4. So this is my original equation. So what do we do with this original equation? Well, you add 4 to top and bottom, and that should equal to the original plus 1/8. That's what we're gonna look. That's what we're looking for. Isn't that what we're looking for? Right? Do you see what I'm saying? We're basically plugging it back into our equation, right? Right. The original equation, you add 4 to the numerator and denominator. It should equal to the original fraction plus 1/8. And does it equal to that? Well, we have to have so we get 7/8 equals to 7/8, right? 3/4. What do you multiply top and bottom of 3/4 by? 2/2, and it does come out to be. Yeah. So the original fraction what? 3/4. Okay. Does this make sense, class? How many people got 3/4? That's the original fraction. Okay, good. Now, if you didn't, do you see why? That's the original fraction. Does that make sense? We didn't get to do example 2 and 4. Don't worry about it. With these, you should be able to do your homework for tonight. Okay? But the rest are very similar. Can you do something like this for your homework tonight? Do you think you have to remember how to factor trinomials? Yeah. If you don't, you can't get the answer, right? You gotta remember those. All right. Good.